All right, so first things first, look at the wedge and transducer, see how their coupling is. If you look closely at the interface between the two, you get a little dot right there, and that's going to make it to where not all the sound is going to be able to come out in that spot. So we need to take this off and reapply the coupling. All right, so we'll go and clean this up with a rag. Same on the transducer. And then to make it easier, you can start the screws and put the coupling on here in a second. Okay, now it's started. All right, now you can get your coupling, in this case for calibration, 3-in-1 oil. You can just squirt some in there. Try not to make too much of a mess. And then snug the screws down. And just snug on both of them, and give it a nice little bit extra. And then wipe off the transducer and we'll take a look. And make sure we got enough. All right, so let's look and make sure we have enough contact. Now, transducers like this style, they have some air holes next to the screws where you might see some bubbles, and that's fine. That's out of the actual transducer area, like that one up there. And that's fine. But looking around at the actual transducer contact area, it's looking nice. So now, clean it up a little bit more. Now we can hook up our BNC cable. Lock it in place. All right, so the first thing we're going to do is get our BIP location and set our horizontal linearity. All 4 steps of this are equally important. None of them are more important than the other, but it is important that you do the calibration in this order. Otherwise, you might be off a little bit on some of the later steps if you don't go in order. So right now, we're going to be looking at this 1-inch radius and this 4-inch radius. And that is 1 inch and 4 inches away from this 0 mark right here. So if, as you can see, that line is, 1 inch, regardless of the angle that you're shooting, within reason. So any of the 3 major angles, 45, 60, and 70, this is the exact same distance to any of them. And same with the 4-inch side. Let's see, let's put our 4-inch mark right there. And it's, 4 inches everywhere. So first, we're going to get our indication from the 1 inch and try to maximize it. So you see that coming up. I'm on a 10-inch range, and so each vertical line on the screen is going to be representative of 1 inch of sound path traveled. So let's try to get our peak indication from here. We can turn it up a little if we want to, but the 4 inch will be higher on the screen. Let's see. Okay. It looks like that is going to be our peak right there. So let's hold it in place and adjust the 0 on the machine. So on my screen, what we're looking at is the G1 peak path. That red box right there. We're going to bring the 0 down. Just a hair. Get it to show exactly 1 inch. Almost there. It's easier to do on the crop crammers. Too far. Okay. So the 0 that this machine shows, as you can see right there, it shows the actual inches of offset that you're doing. And then in parentheses is the microseconds, the US, which is on the crop crammers, the delay or 0, the probe delay. It just shows it in microseconds. So it'll always be somewhere around there. And what you're doing is you're essentially taking out this area where it's traveling through, nothing that we care about. So the actual 0 start point is at the interface. And so that's what we're trying to verify. Otherwise, all your dimensions are going to be off. And then when we do the 4 inch here in a second, that'll be the easiest spot for us to locate our bit, because on this side you have to hang off the edge, by a decent amount to peek up on this slot, because it only goes in, about 1/8 inch or so. And then we'll flip over and point it towards the 4 inch side, which we can see. It's a lot easier to peek on this, but just move it around a little bit, twist it this way. It affects your output. And this is a lot easier on the crop crammer, because you have a freeze function. All right, so we're going to use that. All right, so the 1 inch, we calibrated the sound path to fall exactly on 1 inch. And so this one, as you can see, it's 3.966. So it's a little bit lower. So in order to spread out our sound this way, because right now they're a little too close, we need to spread it out a little bit so that the 4 inch reads exactly right around 4, and the 1 inch reads right at 1. So we'll go over to the velocity setting on here and bring it up a few bumps. And you can look at your velocity table. So the standard velocity for mild steel is 0.13 for shear. But then you can put that in there and adjust it like what we're doing right now in calibration to get the exact amount of velocity that you need. Okay, 0.39, 3.98 something. So then let's go and move it up a little bit. So you can see it instantly, I'm not moving the transducer, it instantly increases. Now we're at 4.09. So let's flip it around to the 1 inch, peek up on it. We need to go. So that's at 1.066. And that's at around 030, 050. We need to bump it up a few more. Now we're at 64. Okay, so we're just a few thousandths off, so let's bump it up one more. And then we'll bring the 0 back down and shift them all back to the left a little bit. Bring them all back to 1 and 4. All right, so that's exactly 1. About. All right, and then we'll do the 4. Let's put a little bit more. There we go. All right, so we are just about as close as we're going to get. And so this is the point of doing the horizontal linearity is to make sure that what you're scanning in the range that you're calibrating for, the thickness range, it makes sure that what you're hitting, the machine picks up and the machine picks up the right distance. If you're off by a lot, then you're gonna, I mean, it could be showing you that there's an indication half an inch away from where it actually is. So this is really important. And then we're gonna find our BIP while we're here. So let's go back and get our peak. right around 4. There we go. All right, so right here, you have the 0, the main 0 line. And then your transducer, or the wedge, it has that angled line right there. That's where it's saying that the BIP should be, you know, from what the manufacturer of the wedge put on there. But the actual BIP on this one, I mean, it's pretty close. But you'll mark where it is, or note where it is. Actually, because it could be, you know, it could be right here, which is behind the line slightly. And that's where you pull all your indications from. Like your distance, your surface distance. Which is 3 3/4 of an inch. We'd pull from that mark. So it's hitting it, you know, around here, which is a little bit closer in. So that's where the actual flaw is, because that's where we're hitting. So yeah, that's how you find your BIP and set your horizontal linearity for the 1 to 4 inch range. You can also do the same thing with 4 inches and 9 inches. Your 9-inch reflection is, so your 4 inch is the same. The sound's going into the steel right here, doing the 4 inches of travel through there. Sound bounces back, and then, you know, gets received by the transducer, but then some of it comes back to here, and then comes back, and which adds that inch, which is, you know, so that's 4 inches, 8 inches, 1 inch. So that's why you can get to a 4 and 9 as well. So when you're scanning thicker materials, like, you know, 2-3 inch beams, where your sound path and skip distance is going to be more than 4 inches, this is where you want to calibrate to the 4 and 9 inch range. And you do the same with this. You have your 4 inch calibrated, and then you'd calibrate your 9 as well using the same technique.